We already have the formulas, a couple of formulas for the area of a triangle. We know from geometry that area equals 1/2 base times height. If you have a triangle whose base you know and whose height you know, you can find its area. But you don't always know what that height is. So in this class, we came up with another formula, 1/2 AB times the sine of C. In this case, you can find the area of the triangle if you know one side and another side and the angle between them. Well, sometimes you don't have that either. In this video, we're going to take a look at how to find the area of a triangle if you know the lengths of all three sides. This is the side, side, side case, and so it shouldn't come as too much of a surprise that this falls under the category of the law of cosines. It's in the law of cosines section in the textbook for this reason. Rather than just give you the formula, although you can certainly look that up in the textbook, I want to show you where it comes from. Let's take this formula here. If we square both sides of this, we get a squared equals 1/2 AB sine of C, all squared. Well, remember, I'm going to go to the top right-hand corner here. Remember this idea? xy squared is equal to x squared y squared. I'm going to apply that here now. This is going to be 1/2 squared times a squared times b squared times the sine of c squared. Well, 1/2 squared is 1 squared over 2 squared, a squared, b squared. Let's write this as the sine squared of c. All right, I'm going to rewrite it one more time. 1/4 a squared, b squared. Now, remember this formula? Sine squared of x plus cosine squared of x equals 1. I'm going to write the sine squared a different way. I'm going to subtract the cosine squared of x from both sides of this equation, and I get that one way to write the sine squared of x is as 1 minus the cosine squared of x. So that's what I'm going to do here. I'm going to write this as 1 minus the cosine squared of c. Well, 1 can be thought of as 1 squared. So now what I have is the difference of squares. So I'll rewrite this again. Area squared is 1/4 a squared b squared times 1 plus the cosine of c times 1 minus the cosine of c. And for some reason, your textbook has the 1 minus first. It doesn't really matter, but we'll just stick with that. All right, now I'm going to erase this scratch work, and I'll erase this while I'm at it. And we're going to do a little bit more remembering so that you'll know where this next step is coming from. One way to write the law of cosines is as c squared equals a squared plus b squared minus 2ab times the cosine of c. I'm going to solve this for the cosine of c. First, by subtracting a squared and b squared from both sides, so that I have c squared minus a squared minus b squared equals negative 2 times a times b times the cosine of c. And then I'm going to divide both sides by negative 2ab. So I have that cosine of c can be written as, let's change the negatives while we're at it. Let's make this side the numerator negative and the denominator negative. I'm multiplying by a -1 over a -1. When I distribute this, I'm going to get negative c, but I'm going to get positive a and positive b. So that means my numerator here can be thought of as a squared plus b squared minus c squared. And then in the denominator, I just have the opposite of a negative, so that makes the denominator positive as well. 2ab. I can think of the cosine of c in this way instead. So one of the things I can do with this is instead of writing cosine c, I can write this right-hand side. So I'm going to do that here and here. I'll have a squared equals 1/4 a squared b squared times 1 minus all of this times 1 plus all of this. I'll just make a copy of the line above, and then I'll erase the cosine of c and replace it with, in very small handwriting, a squared plus b squared minus c squared all over 2ab. A squared plus b squared minus c squared over 2ab. Right, now it's getting very crowded indeed, so I'm going to erase this work here. I'll write this formula. I don't think we actually even need this anymore, so I'll go ahead and erase this right-hand side, and I'll probably erase this SSS, and we'll use the right-hand column then to finish this. I'd like to have this 1 minus this expression as a single fraction, so I'm going to rewrite this 1 as 2ab over 2ab, and I'm going to do the same thing here. I think I can squeeze one more line in here. A squared equals 1/4 a squared b squared times 2ab over 2ab minus a squared plus b squared minus c squared. I'm distributing my negative as I go here, all over 2ab times 2ab over 2ab plus a squared plus b squared minus c squared all over 2ab. Now I have an a squared and a b squared here. So if I had an a times an a in the denominator, this would cancel. Well, look at that. There's an a times an a. So this a squared cancels with a times a. Likewise, b squared cancels with b times b. All right, now I do want to go to my second column, but I've already tried this once and it doesn't work because I don't have enough room. So I'm going to move my triangles over a little bit. I don't know, strictly speaking, need them anymore, but I kind of want to leave them there. And now I'm going to go up here to continue. I'll rewrite this as a squared equals, I'm just tidying this up now. I'm just cleaning up the version that I have. I have 2ab minus a squared minus b squared plus c squared all over 2 times 2ab plus a squared plus b squared minus c squared all over 2. Now I'm going to factor this numerator and I'm going to factor this numerator. I think I'll start with this one. I can factor this as a plus b plus c times a plus b minus c. Let me show you how I get away with doing that. If I think of a plus b as its own entity, I have a plus b plus c times a plus b minus c. That's a difference of squares. So I can write that as a plus b squared minus c squared. Pretend that a plus b is t. Then I have t plus c and t minus c, which I can write as t squared minus c squared. If I expand a plus b, though, I get a squared plus 2ab plus b squared, and then I have minus c squared. So these two things are equivalent. A squared plus b squared minus c squared plus 2ab. A squared plus b squared minus c squared plus 2ab. I can write this as a plus b plus c times a plus b minus c. So that's how I went from this step to this step. The second one's a little trickier. Let me move some things around just a bit. Never quite give myself enough room. There we go. I'm going to start with this expression here. Let's see, where's my highlighter? I'm using this expression here, and I'll rewrite it as negative a squared plus 2ab minus b squared plus c squared. Now I'm going to factor a negative out of the first three terms. That gives me negative positive a squared minus 2ab plus b squared plus c squared. This expression here is just what we had before, except there's a minus in front of the 2ab. So this factors to a minus b quantity squared plus c squared. If you expand this out, ignore the leading negative sign here. You get a squared minus 2 times a times b plus b squared. And then there's a negative in front. So this factors to this. Now I'm going to reorder these two terms. I'm going to write this as c squared minus a minus b squared. And I can think of this now as a difference of two squares, which I can write as c minus a minus b times c plus a minus b. And when I distribute the negatives now, I get c minus a plus b times c plus a minus b. So I can write the thing I highlighted in white up here as this. They're equivalent. So that's what I'm going to do next. I'm going to put that in this position and also copy down my 1/4. So I'll have a squared equals a, the capital A is area. A squared equals 1/4. I'll have over 2. And then I have c minus a plus b times c plus a minus b. And then I have this factor, which I will try to move up a little bit so that it's in a more appropriate position. All right. Now, trying to get that 2 in there. Now I'm going to do some more work with this. So of course I need some more room. I'll erase what comes below here. If you need another minute to take some notes, I'd encourage you to pause the video. And when you come back, you'll be able to pick up where we left off. Okay, we've got a little bit more room now. I'm going to rewrite the right-hand side here as one big expression, one big fraction first, and then in the next line, I'm going to break it down into 4. Now, that seems a little excessive, but I know that some students still struggle a little bit with understanding the micro steps of algebra. Algebra is the thing that will get you. I tell my calculus students, calculus is easy. It's the algebra that'll kill you. It's the same thing here. Our algebra skills are still very important. So what I'm going to do is break it down just a little more than your book does and remind you that to multiply fractions together, you multiply the numerators. So I'm going to get 1 times c minus a plus b times c plus a minus b times a plus b. That didn't go well. A plus b plus c times a plus b minus c, all over 4 times 2 times 2. And I could write that as 16, but I'm going to write it as 2 times 2 times 2 times 2. And now I'm going to do kind of the opposite, but I'm going to put it in a different form. I'm going to unmultiply not 2 fractions, but 4 fractions. I'm going to say c minus a plus b over 2 times c plus a minus b over 2 times a plus b plus c over 2 times a plus b minus c over 2. Now they're all a little different, this a plus b plus c, a plus, they're not all a plus b plus c. And I don't actually know who came up with this. Perhaps Heron. This formula was named after Heron. Whether he actually came up with it or whether it was named in his honor is, lost in the mists of time. But a plus b plus c seems to be, or some combination of a, b, and b, a, b, and c seem to be pretty important. So let's take a look at what a, b, and c are here. A, b, and c generally are the 3 sides of a triangle. So we say that a plus b plus c is the perimeter of the triangle. And we're going to look at how each of these things compares to a plus b plus c. Well, this one right here is just a plus b plus c, so that is our perimeter. Let's call that P for now. And I'm going to rewrite this as a squared equals, I'm just going to do one term at a time, so one factor rather. This one's going to be P over 2. P is just my perimeter, A plus B plus C. Now, let's take a look at C minus A plus B. I would very much like this to look like A plus B plus C. Well, it's negative A plus B plus C. Let's write it that way. Negative A plus B plus C. If I want to add a plus A, so I have an A plus B plus C, then I also have to subtract an A. And that means that this can be written as, or thought of as, let me do this real quick first. There's my P minus 2A. So my first factor here will be P minus 2A all over 2. Okay, let's do the next one. C plus A minus B is equal to C plus A minus B. No surprise there. Let's rearrange this so that it says A plus C instead. A plus C, and it's plus C. I'm going to write this as plus B, but if I have a plus B there, I need to add an extra minus B. This becomes A plus B plus C, which is my P, minus 2B. So my second factor is P minus 2B over 2. And my last one, A plus B minus C, can be written as A plus B minus C plus C minus C. I just added 0 here. Why did I write a 2? I said C, I meant C, I wrote a 2. There we go. I've added 0 here. I had A plus B minus C, and I added 0. But I added 0 in a very particular way. I added 0 so that this piece of it, right here, would be A plus B plus C, and that's my P. So my last factor is P minus 2C, all over 2. All right, now I'm going to erase this bottom 1/3 or so of the screen. Each of these factors now, well, at least the first one, the second one, and the fourth one, I'm going to split those up into separate fractions. I'm going to have P over 2 minus 2A over 2 times P over 2 minus 2B over 2. And then I'll have just P over 2 times P over 2 minus 2C over 2. This is one of those steps that's kind of missing in your textbook. I can cancel the 2's here and here and here, and that leaves me with A squared equals P over 2 minus A times P over 2 minus B times P over 2 times P over 2 minus C. Well, that's just a little awkward. So we give P over 2 a new name. We call it S. Let me write this. In fact, let me do it this way. Now, let P over 2 equal S. Then we have A squared equals S minus A times S minus B times S minus C. And we generally like to write that as S times S minus A, S minus B times S minus C. And we can do that because multiplication is commutative. We can move the factors around and put them in any order. Now, if I want to find the area of a triangle, I can use this idea instead. All I have to do is to take S, which I know to be P over 2, and P was A plus B plus C, the sum of the sides of the triangle, the perimeter of the triangle. So find the perimeter of the triangle, A plus B plus C, cut it in half. Put that number here, 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 and here, and you have the area squared. So the area is just the square root of that. I'll erase my square here, as I took the square root of both sides that has the same effect. I'm going to highlight this formula. This is our final result in the theory part of the lesson. This formula is called Heron's formula for the area of a triangle. You need to know that, how do I put this? Where do I put this? S equals P over 2, and P equals A plus B plus C. We can skip that, right? You can go straight to the idea, if this is a perimeter, the sum of the sides of the triangle, we can just call S the semi-perimeter. And now we know that the area of a triangle can be found by taking the square root of the product of the semi-perimeter times the semi-perimeter minus one of the sides times the semi-perimeter minus another side plus the semi-perimeter minus the third side. It's a weird formula, but I'm hopeful that this process has shown you where it comes from. It doesn't come up very often, but it's kind of handy. If you know the sides of a triangle, you can find its area. If you know the two sides at an angle, you can find its area. Or if you know the base and the height, you can find its area. But you don't always have that information. Sometimes all you have is the three sides. Now, sure, you can use the law of cosines. This is a side situation. You can use the law of cosines to find an angle and then use this formula. Or you can turn this into two right triangles. Let's see, what would you need here? I think you'd still need the law of cosines to find the height, and then you could use the first formula, but that requires an extra step. So if you know all three sides, a handy one to remember is Heron's formula for the area of a triangle if you just know the three sides. Let's look at an example. All right, find the area of the triangle with side lengths A equals 8, B equals 17, and C equals 19. This may or may not be a right triangle. We have three sides, 8, 17, and 19. And I don't know that I would even necessarily need a diagram here, but some people just really like a diagram. If you don't like diagrams, you can just ignore them. But what I need here is my formula, first of all. It's the square root, the area is the square root of the semi-perimeter of the triangle times the semi-perimeter minus the length of one side times the semi-perimeter minus the length of the second side times the semi-perimeter minus the length of the third side. So the first thing we're going to need to do is figure out what the semi-perimeter is. Well, I like to think of the perimeter first as being 8 plus 17 plus 19, and then semi-perimeter is just half of that. So let's figure that out. I see 17 and 19 is 36. 36 and 8 is 44. So my semi-perimeter is 22. Easy. Now all I have to do is put that in here, 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 and here. So I'll have area equals the square root of 22 times 22 minus A times 22 minus B times 22 minus C, where A, B, and C are 8, 17, and 19, respectively. The rest is calculator work. We can do some of this by hand if you want. We get 22 times, let's see, 12 minus 8 is 4, so that'd be 14 times 13, that can't be right, 3 times 2. That would be 22 times 14 times 6. You decide at which point you're done doing arithmetic in your head and at which point you want to use the calculator. You're going to need a calculator for the square root anyway, probably. It's unlikely this is going to come out to be a perfect square. Even if this one does, it doesn't mean they always will. We get 1848. And I need the square root of that answer. 42. 0.9884. And there's my answer to 4 decimal places. My calculator gives me 8 decimal places, and it remembers even more than that. But if I'm asked for an answer for the area of a triangle, that's an accurate enough answer unless you're specifically asked for 5 or 6 decimal places for some particular reason. That's how to find the area of a triangle, if all you know is the lengths of all 3 sides.